Hello viewers, welcome to Lessons with Philip. And today our topic will be on circle. Now we have a question on the board. What are the parameters we need to understand about a circle before we go to the question on the board? Now you need to understand circumference of a circle. Circumference of a circle. You need to understand what you call the arc of a circle. You need to understand what you call the chord of a circle. You need to understand the diameter of a circle and the radius or radii of a circle. Radius is plural. Radius is singular. Radii is plural. Okay? Now, you need to understand what you call segment of a circle. You need to understand sector of a circle. And you need to also understand, you must be familiar with the angles in a circle. Okay? Now, these are the things we need to come across when we want to talk about the circle. Okay? Now, let me quickly start with circumference. Let me quickly brush through each of these because in our coming classes, we're going to deal with each of them. And today we'll be talking about the arc of a circle. Okay? Now, when we're talking about the circumference of a circle, now, a circumference of a circle is otherwise known as the perimeter of a circle, the total surface of a circle. Now, I have an example in my hand. I have a circular orange in my hand. Now, the whole total surface of this circular orange is known as the circumference of this orange. Okay? Now, if I mark 2 points, assuming that I mark 2 points on this orange, if I mark this point, and I mark this point. Now, the distance along 2 points on this circumference, the distance along these 2 points in this circumference, which I've marked, these 2 points is on this circumference. Now, the distance along 2 points on this circumference is known as the arc of its circumference, the arc of its circle. Okay. Now, if I have a circle, if I have a circle like this, so if I mark 2 points on the circumference of a circle, now the distance along from this place, let me say I mark this place A, I mark this point B. Now the distance between these 2 points, this distance along these 2 points on this circumference is known as an arc. So from this place, if I measure this place to this place, it is known as an arc. Okay, now from this point also to this point is also an arc. But if you check the longer one, there's a longer one, there's a shorter one. So this one from this place to this place, from this place to this place, which is so short, is smaller. It is called a minor arc. It is called a minor arc. While the one that is longer is called a major arc. Okay, the longer arc is known as the major arc, while the minor one is known as a minor arc. If you see, I have cut this orange in this form. Now, the distance between this place to this place, as you can see, is known as an arc. So this length, because it is small, it is known as a minor arc. While the rest, from this place down to this point again, from this length to this place is known as an arc, which is longer than these edges. So it is known as the major arc. So that's how to identify an arc. An arc is the distance along 2 points on the circumference of a circle. Okay, now you've gotten that. Now, what about a chord? Now, a chord, don't forget, I've said circumference is also known as what? Perimeter is also known as perimeter of a circle. And perimeter of a circle is given as 2 pi r. We're going to get there. We'll be starting from there, okay? Since we have a question, I'll be starting from there. Then we'll go to the length of an arc. Now, what about a chord? Now, a chord is the distance between 2 points on the circumference of a circle. Now, as we have seen now, a chord is defined as the line that joins 2 points on the circumference of a circle. These are 2 points now. on the circumference of a circle. Now, if I draw a line to join these 2 points, I've drew a line to join these 2 points. Now, this line that I drew to join these 2 points A and B, which are on the circumference of a circle, this line is known as chord. Okay, they are chord. Like you've heard about chord that you use to tie things together. Now, a chord is a line that joins 2 points on the circumference of a circle. Now, a diameter is also a chord. Okay, now a diameter is a chord, is just a special name. A chord, don't forget, we have the center of a circle. Any line, any chord that passes through the center of a circle is specially known as a diameter of what? Of a circle. So a diameter is a chord which passes through the center of a circle. Secondly, a diameter is the longest chord in a circle. So the longest chord is known as what? Diameter. Number one, you must know that a diameter is a chord. Two, you must know that a diameter is a line that passes through the center of a circle. Okay. The third thing you must know is the diameter is a line that passes through, is the longest line that passes through the center of a circle. These are the things you must know about diameter. What about radius? A radius is a line that starts from the center of a circle and touches any part of the circumference of a circle. Okay? A radius is any line that comes from the center of a circle. If this is the center of a circle, a radius is a line that starts from the center of a circle and touches a point on the circumference of a circle. If a line starts from this center and it just touches one point, let me say this is a point on the circumference of a circle. If a line comes from the center of the circle and it touches one point on the circumference of a circle, that line is known as radius. Okay, that's how to know our radius. What about segment? A segment consists, okay, let me draw this now, so that you understand better. Now, when a chord divide, don't forget, anytime when a chord divide, don't forget I have 2 points. So when you draw a chord to join 2 lines of 2 points on the circumference of a circle, this chord divide the circle into 2 halves, not equal halves, either equal or not equal. Now, this half is known as segment. Why the other one too is also a segment. Now, a segment consists of 2 things. It consists of chord and it consists of arc. This one, which is arc. Okay. Now, a segment will have both chord and an arc. So, a segment is a portion of a circle which is divided by a chord. Okay? Don't forget, a segment is a portion of a circle which is divided by a chord. Okay? Don't forget, chord, in this case, chord. Okay? Now, what about sector? A sector is also a portion of a circle which is enclosed. A segment is enclosed by a chord, but a sector is enclosed by 2 radius. Now, a sector is a portion of a circle which is enclosed by 2 radius. Okay, now when I have 1 radius, 1 radius. Now, this aspect is known as sector because it is enclosed by 2 radius and an arc. Okay, now for a segment, it is enclosed by a chord, okay, and an arc. Okay, this is a segment. Okay, while this is a sector. See the difference. One has arc and chord. One has arc and 2 radius. So this is the difference between a sector and a segment. Both of them is a portion. This is a sector now. Let me show you a sector. This is a sector. Okay, you see the way it is cut. This is sector. We have, you see, we have this line and we have this line. You see, it's cut here, it's also cut here. So this line is a radius, this is another radius, because this is center of the circle. So it is cut here, it is cut here. So these two lines are radius. You see, I bring it out. So this is a sector, this is also a sector. So because this one is small, it is called minor sector, while the one that is big is called major sector. So this small one is called minor sector, while this one that is big is called major sector. Okay, do you get it? Now, permit me, supposing I cut this rest, I cut this one down, I cut everything down. So what I'll be having only two halves. Those two halves are known as, this small ones is known as minor segment, while this one that is big is known as major segment. Do you get it? And that is why when we're small, if you want to divide your orange, after you peel it up, you cut it. And most of us will cut one big one and one small one. We give the small ones to people that are small, while we take the rest. Okay. Now the small ones is known as the minor segment, while the major one is called, the bigger one is called the major segment. Okay. Now let's go into angles in a circle. I'm just trying to brush up this so that we know when we get into each of them, you appreciate how deep they are. Now, angles in a circle. Now, take for instance, a law says sum of angle in a circle is equal to 360 degrees. Automatically, when I have a circle, if I have a circle, all the angles, if you add them together, they will be equals to, if this is x, this is y, this is m, this is n, x plus y plus m plus n will give us 360 degrees. Okay? Now, there's another law that says angle subtended in a semicircle is perpendicular, is equals to 90 degrees. Another law says angle subtended in a semicircle, angle subtended in a segment are equal. Okay? Now, don't worry. When we get to angles in a circle, you'll understand better. Don't let me go deeper into that. So just follow the classes so that you understand each individual of these parameters of a circle. Okay, but today we'll be starting with the arc. We'll be talking with the arc of a circle. Okay, let's go. Now we have a question on the board. We want to start with an arc of a circle. Don't forget, I have said an arc is what? The distance, the length between 2 points on the circumference of a circle. Okay, now from this point, this point, down to this point is an arc. While this point round to this point is also an arc. While this one is longer, it is called a major arc. While this point to this point is also an arc, but it is called a minor arc. Do you get it? Now, if you get that, let's go straight to an example we have on the board. The question says, if O is the center of the circle with radius 14 centimeters, we have to calculate the length of an arc MN, okay, if it subtends an angle of 120 degrees, if the arc has subtended the angle of 120 degrees. Okay, now we are only told to find the arc MN. It can be this major arc. We are not told if it is the minor arc or the major arc. But let's just calculate the minor. I will tell you how to calculate the minor arc and the major arc. Okay, now let's try to start from this. Perimeter of a circle. Now, perimeter of a circle. The perimeter of a circle, which is also known as circumference, is equals to, the formula says 2 pi r. In this question, if I have to find the circumference of this circle, okay, now the circumference of this circle, according to what we're given, will now be, always take pi. If you're not given, you can take your pi. Your pi is a constant. Your pi is equals to 22/7, or what you can use 3.142. Sometimes you can be given in decimal, you can be given this. If you're not given, just use this. Okay? Okay. Now, our circumference will be equals to 2 times 20. I want to use 22/7 multiplied by my radius is what? My radius is 14 centimeter. 14 centimeter. 7, if I want to calculate this now, 7 year 1, 7 year 2. Automatically, my circumference will be what? 2 times 22 is what? 44 times 2, that is 88 centimeter. That will be equivalent to 88 centimeter. Okay? Now, if you have gotten that, we are not asked to find this. I just want to start from this. Okay? That if you have to find the perimeter of a circle, or you have to find the circumference of a circle, this is the formula you use. Take note of that formula, please. Take note of that formula. This is formula 1. Formula 1. Because you come across different formula and different theorems. Okay, now let's go straight to our question. We have to find the arc of a circle. Now, the length of an arc of a circle, the length of an arc of a circle, which is otherwise known as L, is given as theta over 360 degree multiplied by 2 by r. Some people say it's also the same thing as theta over 360 degree multiplied by pi times diameter. If you are given diameter, you can use this formula. If you are not given diameter, you are given radius, you can use the first one. Okay? Don't forget, 2 radius makes a diameter. If I have a circle, this is the center of a circle. If I have this radius and I have another radius, this is the center. This is radius. This is radius. The whole length is what? Diameter. So 2 radius makes a diameter. Okay? Now, so that's why if you're given a diameter, you can just use this. If you're given radius, you can use the first one. Now, according to what we have to find, the length of an arc, the length, let me define this. Now, the length of an arc, the length of an arc, MN. Don't forget, anytime when you see letters or a letter having a bar on its head, this bar means line. They can write it like this. This MN they are writing. The line MN, that is line MN. It can be written like this. It can also be written in this format. 2 lines. The letters are in between 2 lines. Take note. This is line. If you see this in mathematics, it is known as perpendicular. Okay? It's known as perpendicular. If you see this, if I'm writing this and I put 2 lines together like this, this is parallel. It's known as parallel. Parallel. Okay? All right. Now, the length of an arc, MN, let's assume that we have to calculate this minor arc of a minor arc MN is equivalent. The formula is theta over 360 degree multiplied by 2 by r. Okay, now what is my theta? The theta is the angle that the arc subtend, which is what? 120 degree. And this will be 120 degree divided by 360 degree multiplied by 2 times my pi. I want to use, since I use 22 over 7 here, this 22 over 7 multiplied by my radius is what? 14 centimeter. All right? Okay? Now, 7 year 1 and 7 year 2. Okay? 120 year 1, 120 year 3. Automatically, I have 2, I have 22, I have 2, and I have 3 left. So, don't forget, this is our formula. This is our formula 2. Okay? Take notes. Now, from this, the length of an arc will now be equivalent to 2 times 22, that is 44. 44 times 2 is 88. That's 88 divided by 3. And 88 divided by 3 should give me, if I use my calculator, 88 divided by 3 will give me 29.33 29.333. We have too many threes. Okay, we have a lot of threes at the back, so it's equivalent to 29.33 centimeter. Because I shorten this answer always because I have many digits at the back. Always put this is to two decimal places because I shorten the answer. Okay, now this is what I'm asked to calculate. In some cases, you may not be asked to calculate the length of an arc. Some cases you may be asked, okay, let's try something. Sometimes you can be asked to calculate, if I'm asked to calculate the major arc now, I want to calculate the major arc, which is from this place to this place. Now don't forget, I've told us that the sum of angle in a circle is equal to 360. So if this is 120, the rest of the angle from this place to this place will be what? This will be 240 degree. So 240 plus 120 will be 160. So if I'm asked to find, this is a circle. Okay. Now I find the length of from this point down to this point is what we have gotten to be what? 88 centimeter. Now I've gotten this point to this point to be what? 29.33. So if I'm asked to find this point to this point, automatically the major arc, let me find what I can just do, since I know the whole, I know the total, the perimeter of the circle, I can just remove the minor arc. Don't forget, the minor arc and the major arc will be equivalent to the whole perimeter. Okay, that is one way. Another way which I can just prove, let me use the formula. So if the circle is this, the arc is this. Okay, now this one is 240. This is the angle I will use because that's the angle that subtend the arc. Now I will use, if I want to calculate the length of the major arc will now be equal to theta over 360 degree multiplied by 2 pi r, whereby my theta in this case is what? 240. That is 240 degree over 360 degree, all right, multiplied by 2 multiplied by 22 over 7 multiplied by 14. Okay, as usual, 7 year 1, 7 year 2. Okay, 0 will cancel 0. Okay, something can go 12 year 2, 12 year 3. So I have 2 times 2 times 22 times 4, 2 times 2. So I have 2. 2 times 2 is 4. 4. That is 2 times 2 times 22 times 2 will give me 176. Automatically, I have 176 divided by 3. And 176 divided by 3 will give me 58.66. I have a lot of 6 at the back. So I have, that is equivalent to 58.67 centimeter to 2 decimal places. I round it off to 2 decimal places. Now, this is the length of the major arc. But in another way, I can decide to use, since I know I've calculated the minor arc, which is 29. I just want to prove it out. Now, the length of the major arc can be equals to circumference or perimeter of the circle minus length of the minor arc. And circumference is what? Is equivalent to, where is it? 88. I have 88 centimeter If I want to subtract the length of the minor arc, which I've gotten to be 29.33, that will still give me, let's use our calculator to confirm, 88 centimeter minus 29.33. That will give me 58.67 centimeter. Have you seen it? Okay, sorry. Have you seen it? Now, in this case, we have 58, and when I calculated it here, I still have 58. Okay, now it depends. Okay, which one you has to find. If you has to find the major arc, you can first, if you know, you can start from here. Since you know this angle, you can just find this angle whereby you calculate directly. So I'm just trying to confirm that sometimes if you has to find the perimeter of a circle, you use this. Okay. Now, in another way, you may be asked, permit me to clean this place. Sometimes you may be given the length of an arc and may be asked to find what is known as the radius or the angle of the angle that the arc subtend. Okay, let's assume that from our question, we are given. Sorry, I'm trying to clean the board. Assuming that from our question we're given the length, we're not given radius, but we are given our length, the length of an arc to be, what do we get? We get, the last time we get 88 over 3, 88 divided by 3, right? We get 88 over 3 centimeter. Assuming that this length of an arc is given to be 88 over 3 centimeter, okay? And we have to find the radius of this arc, okay? The radius of this circle. Let's assume that we have to find the radius of this circle. Well, how do we get it? Now, don't forget, since we're given the length of an arc, what are we given? We're given length of an arc to be 88 over 3 centimeter. We're given angle to be 120 degree. We're given the angle that the arc subtend to be 120 degree. We have to find radius. Okay, now since we have to find the radius and we're given length, we still go with our formula, which says the length of an arc is equals to theta over 360 degree multiplied by 2 pi r. In this case, the length of an arc has been given to be 88 over 3, and our theta has been given to be 120 degree divided by 360 degree, okay, multiplied by 2 times 22 over 7. Our pi is 22 over 7, and our radius is what we don't know. Okay, now 120 here 1, 120 here 3. What else can we divide here? Nothing. So we have 2 times 22 times r. So in this case, we have what? We have 88. We have 88 divided by 3, which should be equivalent to 2 times 22 is 44. We have 44 r divided by 3 times 7, that is 21. Okay, I want to make r. So we have, if I rearrange this, we have 88 times 21 equals to 3 times 44r. I try to just cross multiply. Okay, if I cross multiply, this one will multiply this, while this one will multiply this. Okay, now if you have gotten that well, 88 times 21 will give me 1848. We have 1848, which is equivalent to 3 times 44. 3 times 44 will give me 132. 132 times radius. Now, if I want to make radius the subject of the formula, what do? My radius, I divide through divide through the equation by 132. So my radius, automatically that shows 1848 will be divided by 132, and my 132 radius times radius divided by 132 is 132 will cancel 132. So my radius is now equivalent to 1848 divided by 132, and that will give me 14 centimeter. Don't forget, in the question we're given, what was our radius? Our radius was 14 centimeter. And this is how to calculate. If you are given the length of an arc and you have to find the radius, this is the way you can calculate it. Let me also reverse myself a little bit. Now, in another case, you may be given another thing. You may be given the length of an arc, you may be given radius, but not given the angle. Okay? Assuming that we're given the radius to be 14 centimeter, and you are given the length of an arc, but you have to find the angle. In same way we're going to solve it. Okay? You use your formula. Length of an arc, okay? Use the same formula. Since you're given the length of an arc, I'm just trying to try to solve this together. So in this case, we are not giving our angle, that the angle is subtend, but we're giving our radius to be 14 centimeter. Okay? Now the length of an arc equals to theta over 360 multiplied by 2 pi r. Now, length of an arc is equals to 88 divided by 3 centimeter, but our theta is not given, our angle is not given, divided by 360 degree, multiplied by 2 times 22 over 7. Our radius has been given to be 14, that's times 14. Okay? Now, from this, we know that 7 year 1, 7 year 2. Okay, what is? That is 2 times 22 times 2 times theta. And that will give me, this will give me 88 divided by 3 is equals to 2 times 22, 44 times 2, that's 88. That's 88 divided by 360. 88 theta divided theta times 2 times 22 times 2 will give me 88 theta divided by 360. If I cross multiply, then I have 3 times 88 theta equals to 88 times 360. Okay? Now, if I want to make theta the subject of the formula, my theta will be equals to 88 times 360 degree divided by 3 times 88. My 88 will cancel 88. My 3 year 1, my 3 year 120 degrees. So my theta is equivalent to 120 degree. Are we seeing it now? So in any case, either you're asked to, you're given what parameters you're given will determine how you use your formula. What I'm just doing is I'm just making the subject of the formula. Okay, this is how to calculate the length of an arc. Okay, and in our coming class, we're going to deal with the length of a chord of an arc, of a circle. We're going to deal with chord. We'll be dealing with chord in our coming class. Okay, you can just press the notification button so that you get notification for all our classes. Kindly subscribe to my channel. Thank you so much. Bye.